In 2026, northern India faced a devastating and unprecedented heat wave. But what were the underlying forces driving this extreme event? This video breaks down the science behind the crisis, examining the atmospheric, global, and local factors that converged to create one of the most intense heat events in history. We adopt a calm, informative tone, relying on data and visuals to explain this complex climate phenomenon. The 2026 heat wave was not caused by a single factor, but by a dangerous combination of atmospheric conditions, oceanic cycles, and local urbanization. The most immediate cause was a localized atmospheric event known as a heat dome. A heat dome occurs when a persistent ridge of high pressure parks itself over a region. In 2026, this high-pressure zone settled over northern India. High-pressure systems compress the air beneath them, causing it to sink and warm up. Critically, this pressure also acts like a lid, preventing heat from rising and dissipating, trapping it near the surface. A major global influence that exacerbated the situation was the presence of a Super El Niño event in the Pacific Ocean. Super El Niño involves the significant warming of the central and eastern tropical Pacific Ocean. This shift in ocean temperature dramatically alters global weather patterns. In the case of India, a strong El Niño is known to weaken the Indian summer monsoon, reducing rainfall and delaying the onset of the cooling rains, leaving the country vulnerable to prolonged pre-monsoon heat. On a local level, the structure of India's major cities created a secondary layer of heat intensification, the urban heat island effect. An urban heat island is a metropolitan area that is significantly warmer than its surrounding rural areas. Materials like concrete and asphalt absorb and store solar heat during the day, then slowly re-radiate it at night. The lack of trees and green space prevents natural cooling, locking in the dangerous temperatures. The final and most foundational factor is anthropogenic climate change, which loaded the dice for this extreme event. Climate change has raised the global average, quote, baseline temperature. Think of this baseline as the starting point for every weather event. When a natural variation, like a heat dome, occurs on this higher baseline, the resulting temperature peak is far more frequent and more severe than it would have been decades ago. The 2026 heat wave was a stark illustration of interconnected climate forces. It required a localized heat dome, exacerbated by the global Super El Niño cycle, intensified by the urban heat island effect, all built upon a climate change-induced elevated baseline. Understanding these mechanisms is crucial for developing adaptation strategies and building resilience against the extreme weather events of our changing climate.